My name is Samantha Quiñones. I'm going to talk to you a little bit today about data pipelines. A little bit about me, if you're not familiar with me, I'm a software engineer. I've been in the business since about 1997. I actually used to be a COBOL programmer. So I'm going to talk to you today about COBOL, well, I just did, about JavaScript, some Java, maybe even a little Python. I'm not going to be talking a lot about PHP, just maybe a little bit. I've been in the media space since 2012. So I spent the first half of my career in financial services. I worked for Visa for a decade, left financial services, and moved into the media space. And I've been with AOL, which is a digital media company, since 2014. I'm also the organizer of the Washington, D.C. PHP user group. So if you're ever in Washington, D.C. in the States, please come by. We'd love to have you. If you're interested in following me on Twitter, which is the best place to reach me, I'm at @IEatKillerBees. Or you can find me on my website if you can somehow remember how to spell my last name. So I mentioned that I work from AOL. I can kind of see you guys over the lights. Who is not at all familiar with AOL? Awesome. Who thought AOL went out of business years ago? Yeah. So AOL was merged with Time Warner, and then in 2009, the two entities separated, and AOL was spun off as its own company, and we're in the digital media space. So we actually own a bunch of media properties like the Huffington Post, Engadget, TechCrunch. We're also a big player in the video advertising market. Right? So we do demand-side advertisement stuff. Yeah, we have those annoying interstitial video ads on your mobile devices. That's like all us, sorry. We're actually a very, very large company, but for the last few years, we've kind of put the brands, like the Engadget brand, Huffington Post brand, in front of the AOL brand. So most people haven't heard of us, although we are still one of the large players in the digital media space. So the reason that I asked that question, when AOL reached out to me a few years ago, or a year and a half ago, to come and join them, I said, why? Why would I do that? I don't really want to work for a dead internet dinosaur. But actually, I took the interview because actually the person who reached out to me was really, very interesting. And in my interview, I was asked a really interesting question. So who here hires engineers? I see a few hands. This is a really great question to ask engineering candidates, in my opinion. I kind of like to ask questions like this when I'm interviewing candidates. How would you let editors test how well different headlines perform for the same piece of content? It's a cool question because you can kind of look at how a person works through a problem technically without kind of relying on weird CS questions and silliness that we like to do in this industry. But I want you to keep this question in the back of your mind because it's actually turned out to be a very important question when it comes to my time at AOL. Obviously, that's an example of multivariate testing. Multivariate testing is one way that we can use metrics to improve our applications, right? So there's a lot of different traditional kind of metrics that we look at. Stuff like request response time, cache hit rates, resource utilizations, things that we're looking at to make sure that we're using the hardware that we have efficiently, that we're providing a good level of performance for our users. We use tools like New Relic. I feel like this is perfect because we're in the New Relic room, New Relic track, right? We use tools like New Relic to look at things like our CPU time per request versus throughput. So how much, as we're having more and more throughput, how is our CPU time per request changing? So we see that it kind of reduces as caches get hot. Right? So you can get a lot of really interesting insight into how your application is performing. We can look at our full stack, see where we're spending a lot of time. Yay, PHP. Actually, a lot of this is actually caching layer stuff. So we have a very complex caching thing that I won't get into. But we can kind of look and see where potential bottlenecks are in our stack. This is all really important because perceived performance is vital. So when users are interacting with your application, anything under 100 milliseconds is almost imperceptible to the human brain. As you move up to about 300 milliseconds, there's a small perceptible delay, but it doesn't really register as a problem. It's when you get to around a second that the brain starts to think that that maybe it's not just the system working hard. And actually, that kind of delay area can sometimes be important. So have you ever worked on an application where you Or maybe you've not worked on an application, but it's not uncommon for applications to inject an artificial delay during login when password negotiation is too quick, right? When you get past a second, up to about 10 seconds, the system is perceived as slow, eventually broken. And after 10 seconds, 10-second response time, generally speaking, you'll have lost your user. This can have a real impact on revenue. So Amazon did a study in, I'm trying to look at my notes, and they're so super tiny, 2006, where they looked at the effect of latency on sales. And they saw that with each 100 milliseconds of increased latency, they saw about a 1% drop off in sales. So I don't know what Amazon makes every second. Probably $2,000 or $3,000, I would imagine, in revenue. That can be a huge amount of revenue lost, right? And for a company like Amazon that actually keeps, stock, like those margins are very, very small. For Google, they did a search experiment where they injected artificial latency into some of their search responses, and found that as the latency increased, the number of total searches went down. Right? So Google makes their money the same way that AOL makes our money, right? We put ads for, Honda Civics on the internet, and the more of those ads we put in front of your eyeballs, the more money we make, right? So Google's in that same business. So for us, it's all about page impressions, right? So you can see that you can have a tremendous drop-off in your revenue by having a very small, this is talking about additional milliseconds, 150, 100 milliseconds of latency, can actually have real bottom line impact. And then to go back to what I talked about a few minutes ago, multivariate testing, right? This is where you take your users, you sort them into groups, right? You have a control group and you have treatment groups, and you give them different content. And then you measure behavioral statistics like click-through rate and abandon rate, right? To see how different types of content are received by the end user, right? So this is a way of looking at the performance of design elements, or even the performance of content itself. Something that doesn't often get talked about when we talk about metrics is state monitoring, right? So logging. So who has a distributed application but does not use centralized logging? I'm glad I don't see any. I see a couple hands. It's vital to understand, it is a vital aspect of performance monitoring to understand what exceptions are being thrown in your application. What is the general load at the individual webhead? Right? What is the system performance? What is the cache performance? And we get a lot of this out of having applications that log to a centralized logging repository. And a big thing for us, especially because we're in the advertising business, and I'm going to try not to make it sound like we're too creepy, just a little creepy, a good amount of creepy. Traffic metrics. So trying to understand the people that are interacting with our content, like who they are, what are their maybe what's their gender, what's their age, what's their income range? Are they more interested in seeing ads for Honda Civics or, for a nice Bentley? Right? We want to look at user behavior and experience. So we want to understand what is the user clicking on. I think I just knocked my microphone off. What is the user clicking on? Where are they coming from? Where do they visit when they hit the site? Where is their mouse going? Right, so we can follow where their mouse is on the page. We do a lot of real user monitoring. So monitoring how long it takes for the JavaScript on the page to load. How long do all the DNS lookups take? Are we causing an excessive delay when users' browsers are loading our content? Right? How many of you have seen this? This is the Dreamscape Multimedia. Did this, I think, in, I don't remember. It was a while ago. Where they did, this is actually not mouse tracking, this is eyeball tracking, right? So they're tracking where the eye is looking at the screen. And they kind of found that this pattern exposes itself over and over again where sort of the eye is drawn to the upper left corner, right? So if you look at the way that Google kind of lays out their page, their search results, which is, this is where Google makes their money, right? This is their money page. Their most important stuff is right where the eyeball goes first. Right? So this is a way that we can use user monitoring to understand how we can improve the performance, in this case the revenue performance of our applications. And we do a lot of demographic collection. So we collect information about, like I said, the anonymized user information. So we'll try and figure out who a user is, not like who that person is, like it's Joe Smith, but like this is an individual human being, and we'll maybe try and figure out some facts about that human being. We're not really that interested in who that person really is. What devices they're using, what ISPs they're using, the geographic location that they're in. If we can't get that, at least the region. Are they in the UK? Are they in the EU or in the United States? Right, so we do all of this as part of something called the AOL Media Platform. Right, so I mentioned before that we have a whole bunch of brands. All the brands live in this big multi-tenant system called the AOL Media Platform. So it provides content management, distributed rendering. So this is a PHP stack, serves a couple 100 million page views a day. We don't use any front-side caching, so every time you hit one of our properties, there's PHP being executed, right? So this big, massive rendering farm. These websites are developed, generally speaking, using a custom DSL inside of an IDE that we develop and maintain. We have a content aggregation platform. We have a distributed machine learning platform. So we aggregate content from all of our brands and also from external partners. And then we run it all through a machine learning platform to try to understand what it's talking about. Stuff like that. And like I said, this is a big multi-tenant system. So we have lots and lots of brands living in there together at the same time. I want to talk to you about basically what I was brought into AOL to work on, right? So when I started with AOL, these are the 4 things that we had for metrics and analytics. So we use Omniture for revenue analytics, New Relic for application performance monitoring. We also have a lot of ELK infrastructure. Is everybody familiar with ELK, the Elasticsearch, Logstash, and Kibana? Okay. So it's kind of like an open source way of collecting, like open source Splunk, if you're familiar with Splunk. And then we have a proprietary data platform called we call it the data layer, which is used for collecting RUM and demographic and traffic information, right? This is a massively distributed data collection network. It's based on Hadoop. So essentially we have a big giant data store where we just collect petabytes and petabytes of data. We use Cassandra to slice some of that data off to make it more readily accessible to different consumers. Part of this is a Vertica installation where we ingest a lot of data from Omniture and then sort of massage it to make it fit with the kind of reporting that we need. And then there's also a streaming interface for raw data. Right? So it ends up looking like this. At the very front, we have these things called beacon servers. And if you hit one of our websites, you might see, if you open like the Chrome Inspector, connections to something called b.aol.com or b.engadget.com. These are the beacon servers. And these are just web servers that are sitting there, they're internet-facing. You throw JSON payloads at them, and they push them onto a RabbitMQ. They're fairly simple. They have some kind of filtering, like to try and filter out garbage, but they're fairly simple. So all of that goes into a giant RabbitMQ farm. And then from RabbitMQ, there are services that pull that data out, push it into Couchbase, push it into Cassandra, push it into Vertica. Everything gets logged into Hadoop. And then all of that stuff also gets pushed into a streamer farm. So this is what drives these data layer streamers. Right? Over here on the right side is, like I said, that raw data streaming interface. So all that data that's coming into the beacon servers up here comes out over here exactly as it came in. The beacon payloads themselves look something like this. Now, they're generally much larger than this, but they're just JSON objects. If you see them in your Chrome Inspector, you can see what's in them. There's nothing particularly interesting. We'll capture the user agent. This makes sense to us. It's a content vertical kind of information. Everything gets assigned an anonymous ID. If you allow cookies, that will persist across different AOL properties. We get the refer, your geographic location if we can figure it out from your ISP information, stuff like that. And then we can actually inject things like multivariate test payloads into here. So we collected this tremendous amount of data. Each one of these payloads, which we call events, contain about 40 different keys. They're roughly about 1.6 kilobytes in size. So they're fairly sizable. We get 15,000 of them a second. Right? So it's about 25 megabytes of data every second. And in the course of a day, we log about 1.3 billion events, or about 2 terabytes of data. Right? So it's a very large amount of data. Not very large in the terms of, maybe in the sense of the whole internet, but for us, it's pretty big. So this is all great, and all this stuff goes into Hadoop, and you can go into Hadoop, and you can run Hive jobs in Hadoop and like extract amazing amounts of data out of the system. But it can take a long time, so that's a time-shared system. We have to share that with other developers who are trying to get at this information. Sometimes it takes a couple of hours to pull information out. Generally speaking, from the time that data hits a beacon server until the time it's available in Hadoop is a couple of hours, right? So realistically speaking, to get information, if you go right now to Engadget.com and click on something, for that data to be available in a report coming out of Hadoop could be 6 hours, right? Our editors don't care what happened 6 hours ago, right? They care about what's happening in the past hour, past 2 hours. They want to know social engagement trends, like who's tweeting about something right now. They're very time-oriented. And then also we have to remember we have all of these developers who are our customers. So we're not just developing a product for content creators. We're developing a platform for software developers, right? So they need to understand a lot of those application performance things that I talked about earlier. How are their API queries performing? How is their cache hit rate? What kind of exceptions is their code throwing? Right? So they need to have this information too, and they don't have the luxury of direct access to something like New Relic or Elk. Right? We live in a 24-hour media cycle, so media trends change hour to hour, and it's very important for us to be like the difference for a breaking news story. Like if some information comes out about Miley Cyrus, I will talk about Miley Cyrus so much. I'm sorry. If there's a breaking news story about Miley Cyrus, if Cambio.com gets to it first, or Gawker.com gets to it first, whoever gets to it first is going to make the money from that story. So it's important to be on top of these things. So anyway, I joined AOL because of this project. I thought it was a really interesting project. And this is actually a unique experience for me in that in the weeks leading up to my, kind of between my old job and the new job, I was in daily communication with my new boss. And we were planning and designing and discussing kind of what this new platform would look like, this real-time data platform would look like. So I had the really cool experience of going to work on my very first day, getting my software so I could sign in, and then immediately starting to work on this project. And the first question we wanted to answer was, how would you let editors test how well different headlines perform for the same piece of content? So that's that multivariate testing question, right? So I want to tell you how we did this with just 3 easy failures. Started with a proof of concept. So over here on the left side of the screen, we have those streamers. So those are the real-time data layer streamers that I talked about earlier. Connecting to that, we have a receiver. So these things generate an HTTP stream. You connect to them over HTTP, and they just start sending you line-delimited JSON objects. So you need something that's going to actually do that, make that connection and consume that data. And then my initial thought was to push all of that into a statsd cluster. Who's familiar with statsd? Okay, I see a lot of hands. So statsd came out of Etsy. It's actually a really cool little tool. It's a very simple Node.js application that just runs, collects data, aggregates it in memory, and then pushes it off to something else. Usually Graphite, but you can push it to Elasticsearch or a bunch of different backends. And in this case, I was pushing it into Elasticsearch. And I wanted to use Elasticsearch because we already have a lot of familiarity with Kibana, right? So Kibana is the visualization tool that lives on top of Elasticsearch. From a logical perspective, it kind of looked like this. So we have a streaming HTTP client. This is built in Node.js. So it's using a native Node stream. We receive the data layer stream, break it off at each line break, create new records for each data layer event, push that onto a message bus, and then a bunch of event listeners that look for those events to get created, and then edits them. Right? So it extracts the information out of them that it wants, and generates statistics objects, which then get pushed out to statsd. Right? There was one good idea here that we had, and that was to kind of encapsulate this editing into tiny little services that were shareable and reusable. This is the only code in this entire system that exists that survived from prototype to production. It's just parsing out a user agent. But using this method, in about a week, I was able to produce something that was fairly usable in that. So I took the screenshot on my 7th day at AOL, where we could actually see on a map, this is not a video, unfortunately, the different countries, the darkness would change as there were the number of hits in the past second would change for each of those different countries, right? So if nothing else, it proved that we could do something somewhat meaningful with this stream of data, right? So the proof of concept, while it did work, we were only able to consume 300 messages a second. So remember, we're talking about a total of 15,000 messages a second. Sometimes that spikes up to 20. So we would have needed around 70 receivers in order to do this, which is an unwieldy number of receivers. And then StatsD actually imposed a bunch of other limitations. So we have these very rich payloads. And these payloads will tell us that someone in Denton, Texas, on an iPad looked at this content. What we see once it gets broken up into StatsD is that someone in Denton, Texas looked at this content, and someone on an iPad looked at this content. We lose that connection between those data points. It was around this time that I realized that in order to build an efficient real-time data pathway, you had to have a network of transits and terminals. This is not any kind of real terminology. This is BS that I made up. But the idea here being that you have no single node that acts both as its transit and a terminal at the same time. That is to say, transits are short-term, volatile places where data lives with a very short lifespan while it's en route to something else. And terminals are where data goes to either be destroyed, stored, or retransmitted. So the first thing that we needed to do was replace StatsD as a transit. Right? So two of the tools that we looked at were Kafka and RabbitMQ. So who's familiar with Kafka? And how about RabbitMQ? OK, so a lot more people familiar with RabbitMQ than Kafka. I'll talk about Kafka first. So Kafka is a pub-sub message broker. It came out of LinkedIn a number of years ago. It's an Apache project now. It's very similar to RabbitMQ in that it's a publish and subscribe message broker, but it's very focused on message integrity. So it's persistent first. Message order is preserved, so you get messages out of it in the same order they go in. And it's highly fault tolerant. RabbitMQ, on the other hand, it's a little bit more mature. It's been around since 2007. It's kind of considered the de facto AMQP implementation. It's much more general purpose. It allows routing. You don't necessarily have a guarantee of message order integrity, although you can get that. It uses federation for high availability as opposed to persistence and sort of sharding. Right? So when you think about our requirements, we're getting these payloads. They're very rich payloads, and they're time-stamped. So it doesn't matter what order we receive them in. When we analyze them, they're going to be analyzed. They're going to be, if we do a histogram, obviously we're going to use the timestamp anyway, so the order doesn't matter. Some data loss is acceptable, right? We're collecting 1.3 billion events every day. If we lose 10% of that, we still have a significant sample size to do analytics against. We have different consumers that may want small subsets of the data, right? So being able to take data and route it based on different parameters is something that would be very, very useful for us. We need to have a broad support for different languages, right? So generally speaking, our big three languages at AOL are Java, Python, and PHP. We have a lot of Node.js lately, too. So having support for those languages would be really, really important for us. And we need to route data between lots of different data centers. And we're right in the process right now of closing our physical data centers down and moving everything to AWS. We have kind of 1 foot in each world. So we're constantly shuttling data back and forth over this network boundaries. It's every bit as horrifying as you're imagining. Right? So I ended up choosing RabbitMQ, right? Because the priorities were very similar to mine. I had the federation over at least once delivery. I don't care if I lose a couple messages. It's not a big deal. I can route messages. I can federate over network boundaries, even though like you really shouldn't do this. You can, especially if you're routing very specific chains of messages across. It's a very small volume. There were mature clients for all of our major application stacks, right? And obviously Pivotal's behind it, so that makes it attractive to big companies, right? So that was the first decision. So I decided to replace statsd with RabbitMQ, right? So now we have the data layer streamer, the receiver, the Node.js application, pushing into RabbitMQ, and then Elasticsearch on the other side. Made a couple of other changes in version 1. I moved away from the observer pattern. So if you remember before I showed you, each time a message came in, we would generate an event, and there would be a bunch of event listeners that would pick that event up, extract data out of it, and generate a stat record. Moved away from that. Why? So Node.js is really, really great at handling events. It's a very, very fast engine. But when you're generating a tremendous number of events all at the same time, you can cause a lot of memory bloat, right? So while that's tunable, and like if you go to the JS community and like say, hey, I got this problem with like generating too many messages, like well, you can write a native module, and you can like okay, you can get around this limitations, but rather than doing that, I wanted to just use the back pressure mechanisms in the native node streams to sort of regulate the input rate. So it ended up looking kind of like this. So we have a streaming HTTP client just like before. We're still breaking apart messages as they come in. Now they go into a process chain, and each one takes the record, performs an edit to it, and then passes it on. And then we get this enriched, edited record that comes out the other side and goes into RabbitMQ, right? So this was fine. This worked great. You do start running into weird things where you're kind of like looking at operations, like I need to pull the first element off of an array in a tight loop. Which one is faster? Right? And just as a general rule in software engineering, when you find yourself kind of thinking about this, either you're a systems programmer or you've done something horribly wrong. This should be the picture next to micro-optimization in the dictionary. So version 1 actually doubled the performance, 600 messages a second in version 1, which means we can cut the number of receivers down to 35, which isn't too bad. But two main problems. Having to do this micro-optimization of code was getting really, really sketchy. And also was having to constantly add code to handle weird edge cases. Like we would get weird data, especially from some of our users in East Asia, where sometimes like people with older computers, they're sending data that's encoded strangely, or not strangely, but just encoded in non-UTF formats, and it would literally just cause Node to crash because there would be like something that Node thought was a null, and it would just it would fall over. So constantly having to write code to handle these weird little edge cases. So like I said, when you're having to constantly deal with weird edge cases and micro-optimizations, you know as an engineer that you've done something horribly wrong, so you have to kind of reevaluate. And I want to point out that me not knowing how to use Node to its fullest extent doesn't mean there's anything wrong with Node. And I realize I don't have to defend Node to you guys, because I'm assuming mostly you are PHP developers. Sometimes it's very easy to dismiss a tool. I think this happens a lot to PHP, right? Like people say, oh, PHP is garbage because their experience with PHP is 10 years out of date. Right? It doesn't necessarily mean the tool itself is broken. So it's around this time that I realized I needed to get very, very serious about what I was building. Receiving data, editing it, and routing it all in the same step violates my transit and terminal separation policy, right? So I'm doing that over here, right? This guy's doing too many things. The receiver should be simple. It should just be a transit that consumes data off of the high-pressure RabbitMQ or the high-pressure data streamer and pushes it into the low-pressure RabbitMQ farm that we control. Right? It would be really nice to build this in something that has static and dynamic optimization, a nice multi-processing model, because it would be much more efficient if we could do these sort of in-memory edits in a number of multiple threads. And something that's good at managing like very large, very volatile data sets in memory, right? So I had a number of different choices I could go with. Obviously, I could stick with Node.js, which is very simple and fast, and that we have a lot of institutional knowledge about deploying and distributing. We could use Go. Go is really attractive for this because of its native concurrency model, right? So if you're not familiar with Go, like it's very, very simple to do like very lightweight threads in Go. Got good memory management. It compiles fast. So for a compiled language, like Go is really, really very interactive. We could use Rust. Could use Java. Java's got a very, very powerful static and dynamic optimization. It's got really great memory management. It's got multi-threading, especially if you use libraries. We could use C or C++, also really, really fast. There's good libraries for handling concurrency and for handling memory management. A lot of downsides, though. For Node.js, I just need too many instances to manage production flow without hyper-tuning the V8 engine, right? While I was really pumped to use Go, and some of the people on my team were like, yeah, that would be fun. It's kind of selfish to like, oh, I'm going to build this in Go, and then I'll be the only person who can support it. Rust, very, very similar, except no one was like, I said, hey, who wants to learn Rust? And just crickets chirping. I know, so I speak at a lot of PHP conferences. I know if I did this in Java, everyone's going to make fun of me. And I just don't hate myself enough to do it in C. I think it's really important as a software architect to understand other people's vision before expressing your own. I think kind of like growing into that role means learning to understand how other people see a solution to a problem. When I first started this project, and I was talking to the data layer team, so they're the people that manage everything to the left of those streamers from that early diagram, they said, you know what, you're probably going to want to build this in Java. And I said, no. It's 2014. People don't build things in Java anymore. I don't want to spend my life writing giant XML files. It's a Node.js world. Baby, get with it. Yeah, I use Java. So version 2. Same streamer as before. Receiver, now written in Java. RabbitMQ. A new component called the processor router on this side. So the processor router is essentially all of that Node.js logic that does the editing of records, the massaging of data, extraction of data, encapsulated in its own processes over on the other side. So I guess what I'm trying to point out here is that this is a very high pressure connection. Like we can't back that up. That is a fire hose over here. This is a very low pressure connection. We can drop records out of this. If we get backed up and drop some records, it's fine. No big deal. So having the Node.js processes over there, we don't run into that same performance issue of trying to keep up with this massive stream of data. And the Java itself, who hasn't worked in Java ever or hasn't worked in Java in a long time? Yeah, so Java is actually not that bad. It actually looks a lot like PHP, or I should say PHP looks a lot like Java. This application is written in very, very bare bones Java, no frameworks. Simple wrapper around a native Java line streamer. Create a bunch of threads. Each thread maintains a connection to RabbitMQ. We have a very, very simple pass-through. So we just basically read the record off the stream, attempt to parse it as JSON. If it parses, we push it over out to Rabbit. Very, very simple. I describe it as a bunch of ketchup bottles. We have network input, a bunch of queues, and then network output. Right, so it's a very, very minimalistic application. From a logical perspective, it looks very, very similar to what it did before. So we have a streaming HTTP client. We cut records at new lines, push it onto the work queue. Worker threads pick them up and generate the raw, send the raw records onto AMQP if they're valid JSON. So I expected to get some performance benefit out of this new version, and I did. Got up to about 2,600 records a second, which means I only would need about 10 receivers in production. In production now I have 12, so pretty close. Validity filtering is almost free in the Java receiver. If it can't parse as JSON, we just drop it. Right? And then the processor and the router service can select only the messages that it wants. Everything else gets dropped on the floor or left for another service to collect. Right? So huge win, right? We're getting that data out of this massive fire hose and into a pool where we can use it. But this is where it just starts. Because without consumers, this pipeline is useless. We have all this data now flowing through RabbitMQ. What are we going to do with it? So I want to talk to you about some of the applications that we're building on top of this pipeline. First thing is our real-time analytics service. So we want to do math at all this data. I guess I should say maths here. That just sounds so weird. So the goals here, provide real-time statistics, metrics, and analytics for the editorial staff. So these are the people, this is geared mostly towards the people who are generating content. They're writing stories. We want to allow them to do a statistical evaluation of arbitrary variables. Right? And we want to provide a simple interface for the developers who are working in the publishing stack. So these are PHP developers. Right? So we want to provide an interface that lets them get at this data without having to go through too many hoops. Right? So, you know, it's been kind of like hanging on the right side of the screen all day. Elasticsearch, that big bubble. Who's familiar with Elasticsearch? Awesome. I love Elasticsearch. I give like 18,000 talks about Elasticsearch. I kind of want to marry it. Elasticsearch has a high-performance NoSQL document store, right? That has there's a high availability via intelligent clustering. It's like got rack awareness and data center awareness built in. It's got a really, really powerful query DSL. I guess it also does some full-text searching or something. I don't know. It's a very, very powerful analytics engine. It clusters out really, really nicely. So remember before I was saying that one of our big issues is moving data around between all of these different data centers and AWS, right? So we can have clusters that live in AWS. We can have them that live in AOL's US data centers, in our EU data centers. It does replication, and it does elastic replication. And so if you decide to add nodes to a cluster, it will rebalance the location of these individual shards, right? So it's a very, very powerful, very easy to scale out data store. For search applications, it's got a really simple DSL, right? So this is actual real code from there's Miley again. Hey, Miley. From one of our sites, Cambio.com, which is a site, a US-based site that's kind of geared towards teenage girls. Analytics queries are a little bit more complex. So we can do things like multi-level aggregations. So in here, what we're doing is we're searching for specific types of events that happen in specific posts. So these are referring to individual articles that live in the system. And then we're extracting out what search referrals led to those individual articles. And then, or I should say, we're parsing out the actual referrals and then making a decision if it is a search referrer, trying to get the search terms back out, right? So we can do these multi-level aggregations. This stuff lets us build dynamic interfaces inside of our CMS that look like this. So this comes from Engadget. I took this screenshot a couple of months ago, where they can come into their dashboard and they see these numbers just scrolling live, showing the page views. And then for us internally, these columns you see over here on the right, social search, internal, and other, refer to where the referrals came from. So whether it came from a social or a search site, or internal meaning from another AOL property, right? So we try very hard to maximize how much we drive traffic from TechCrunch to Engadget and stuff like that, right? Client access is really easy, so we index on the Node.js side of things, right? So we can index a whole bunch of stuff, just create big bulk index requests and shove them over the wire. PHP is super simple. to connect to Elasticsearch using, they have a really great library that Elasticsearch actually maintains, so you can perform searches. So very, very early on in this talk, I mentioned multivariate testing. All right, so allowing editors to test the performance of any concrete element, so things like decks, leads, headlines, subleads, hero images, right? So all the different things that are on a page. And we wanted to be able to let editors do this, create tests, start them, stop them, and evaluate them without actually having to talk to one of their developers, right? Because developer time is expensive. So what can we do? How can we do this? Well, each new visitor that comes into a site gets a cookie. That's how we assign them to a test group. We inject test markers into that beacon payload that comes back over. And then we compare the click-through rate to calculate performance, right? So we have a test population identifier and a test ID. So this makes sense to our back-end databases that understand what these tests are. These are, again, user-defined tests. So as a content editor or a content writer, I can come in here and create a test. I can say, I'm going to write an article. I'm going to give it 2 different headlines, and I want to see which headline gets more clicks. So then on the analytics side, from all that raw data, we can look for page views. We can create a nested aggregation that looks for records that have multivariate tests, pulls out the test ID, pulls out the population ID, and then determines whether it was a click or a page view. And then we can do some very, very complex mathematics to calculate the click-through rate, and we end up with an interface like this. So they can actually come in here. There's no developer involvement here. This works automatically on any one of our content content brands. Any editor can come in there and create 4 different headlines for their article. So why this is important for them? It's not that we couldn't do this under the old system. Before, they could create an article, and then maybe 6 hours later or tomorrow, go and see how the different headlines performed. Now, if you go and click on one of these headlines, these numbers change within 5 seconds. It's 5 seconds from browser to browser, right? Another big thing, mostly that my boss was interested in. My boss is a really interesting guy. He's all about native real time. He wants to see things moving and popping and shining and making noise. He wanted wall maps, right? So how can we create wall maps with this raw data? Well, we can create a socket.io server, use a WebSocket server, let browsers connect to that with a JavaScript client, and stream data right into the browser. Now, obviously, we have to select a subset of messages. You can't stream 15,000 messages a second to a browser. I've tried. It crashes Chrome. Right? So this is where RabbitMQ comes into play. We can select out a small subset of messages, push it out to the visualization service, right? And then we can pump it into D3. Who's used D3? Okay, I see a few hands. So we can pump this into D3. We can use D3 to create a map projection and then draw on that map where each of these geographic points are. And it ends up looking like this, right? So I showed this to my boss, and she's like, oh, wow, that's really cool. And I said, yeah, that sure is a cool map of the English-speaking population of planet Earth. Which is what it is. I shouldn't say that. I mean, we do have actually Korean language properties and Japanese language properties. But actually, this means a lot more to our editors. They put a lot of heart and soul into writing this content. And for them, numbers don't mean as much. This feels to them much more alive and real. They can have an emotional connection almost to this sort of living, breathing visualization of their content out there on the internet being consumed, which is kind of cool. I tried to make this a little bit more useful by color coding the dots, right? So I color code them based on the property. But you don't really, I mean, like the green dots are dailyfinance.com, so that covers like the stock markets, international currency markets and stuff like that. So, I mean, big surprise, popular in London, New York, San Francisco, right? Autoblog, like really popular in like Russia. They're like super into cars there for some reason. One thing that's really cool is like the ability to create embeddable visualizations, right? So, this is a tiny little visualization that we can actually embed next to a post inside of our CMS, right? I don't know if you can see this with the lights. It's kind of dim. Can you guys see this? OK. Now, I won't call this a graph, because if you'll notice, there's no numbers on either axis. This is not a graph. All this is I'll actually show you what this is. All this is we're counting the number of events that happen each tick, and then we're moving the line up and down and doing a spline transformation so that it goes all squiggly, right? It's very, very simple, but this allows people to have a connection to this data sitting right next to their post. They can say, wow, people are really like looking at my stuff. Like, look at it, it's moving. There's a point here where it like jumps really, really high and it looks really, really impressive. It's probably a network glitch where like we kind of missed counting for a second. Right? It's not a really big deal. But these kind of visualizations have a huge impact in a way, there it is, in a way that I think sometimes we as engineers miss, right? Because we tend to be much more like evidence-based. And I want to give some love to the developers too. So like I said, we have all of these developers. We have about a dozen developers who work in my team, working on the core platforms. And then probably a couple of hundred developers who are actually building on top of the platform, actually building user-facing sites. Right? So they're really very important to us. We wanted to give them the ability to profile their code live, right? So they use our API. They have two ways of building on our platform. They can connect to our HTTP API, and they can build using whatever stack they like. They can use PHP, they can use Ruby, they can use Node.js, whatever. But they have to manage their own infrastructure. If they want, they can use our managed hosting platform, right? So we handle all the scaling, we handle all the caching, we do all the hard work, so they can focus on their stuff. So the vast majority of our customers do this, right? The only downside is that you have to work in a custom DSL. Now, it's better than it used to be. It used to be you had to work inside of our IDE. Now we have the ability to let people create their own Git repositories. They write their code. They use this thing called the AMP client, and then they can sync that to a live machine that's out there on the internet where they can do testing and stuff. It's really, really cool. I keep trying to get Ralph to like give a talk about this. Really, really fascinating. It's all built in PHP. All built on Twig. Like the user-facing language is just based on Twig. It's a series of Twig extensions that generate all this stuff. So to profile this code, what we do is essentially the dev starts up a profiler session. So they're in their management console, and they start a profiler session. That gives them a query parameter. So they hit their website with this query parameter appended to the URL. They can do this in production, or they can do it in development. It doesn't matter. Using that token activates the profiling. So all of these event messages that get generated by activities that are happening inside of the system get tagged with that profile session ID. Anything that's tagged appropriately gets routed by RabbitMQ to the profiler service. Right? So the profiler service just sits there, waits for messages. When it gets messages that it sees are meant for a logged-in developer, it routes them to the console. So they can view a waterfall of their code executing. Right? It's not maybe the best example, like, wow, that is a really slow HTTP request. 9 seconds. Bad times. But they can do this, like I said, and they can do this in production, and they can do this in development. So they can actually go and look at their code executing live on one of our 1,200 render servers that are sitting out there, without knowing which server it's on, without having to go and look at logs. The last piece I'll talk about is cross-platform eventing. Right? So I mentioned that we work in a bunch of different stacks. And one of the things that we thought would be really cool would be allow developers to dispatch native events in one stack and then observe them on another. Right? right? So in this case, our CMS is built in PHP. It's not built using Symfony, but we use a lot of different libraries, and one of the libraries that we use is the Symfony Event Dispatcher. Right? So we want to allow a PHP developer to dispatch events using the Symfony Event Dispatcher, and then maybe have another developer who's working in Node.js somewhere consume that event natively. Right? So distributed event handling without PHP workers. So this is kind of how the routing happens, and we've added another direction. So we have these messages that go out to the event handler service, right? The dispatch works basically just by overriding the native dispatch that comes out of the Symfony Event Dispatcher. So we look for events that are forwardable, that implement this forwardable interface. And when we see them, we push them out onto the RabbitMQ. I talked before I clicked. All right, so then we forward them out onto RabbitMQ. So then over in Node.js world, all we're doing here is creating a listener. So there's some bootstrapping code that actually comes in here and reads this out of the exports. But we're here dispatching an event named amp post save. And then here in Node.js, we're listening for an event called amp post save, right? When that event gets sent out over the pipeline, it gets picked up by the event handlers and can be consumed natively in Node.js. Right? So we have a bunch of other stuff that we're building on top of this. To kind of summarize what we're talking about, where we are right now, 1.3 billion events that we're consuming a day. We route all of this stuff through RabbitMQ to different microservice consumers. Right? We're doing real-time analytics on a data set that's about 250 gigabytes of raw data per day. So of that 2 terabytes that we consume, 250 gets routed into our real-time analytics service. We're visualizing 1.3 million events a day and generating live profiles for 50 properties. So we have about 50 different developers at any given time that are in there doing live profiling of code. And we're using cross-platform eventing to handle about 10,000 Elasticsearch search index updates every day. All of this is built in Java, Node.js, a lot of PHP, and especially in the front-end pieces, Python, and the back-end, Hadoop and RabbitMQ, Elasticsearch and Vertica. For 2016, and the rest of the year, so one of the big things that's cool is that we're moving this all into AWS, which on the one hand is horrifying because it's petabytes of data. So we get to be one of those cool companies that gets like FedEx boxes of hard drives to Amazon. That's going to be exciting. A lot of this is going to change because Amazon Kinesis, right? So I don't know if you're familiar, but Amazon has this really cool new streaming service called Kinesis. Some of the things that we're looking to do are real-time sentiment analysis and predictive performance analysis. So we have this plan to create content bootstrapping, to let our content creators know what topics are trending heavily out there in the media world right now that they're not covering. So if they're at Cambio and there's like hot Justin Bieber news that Cambio needs to get on now, right? We want to be able to tell them, hey, we don't know what it is, but there is some Justin Bieber stuff going down right now. You need to get on it, right? So we can do predictive analysis, social sentiment analysis of what's kind of happening in the social world in real time. We continue with this embeddable visualizations. The pipeline, if you look at it as a map, ends up looking like this. So we have the AOL Media Platform and the AOL Data Platform that are generating or inputting into the pipeline, and then the analytics service, visualizations, profiler. Religence is our machine learning platform. So we're in the process right now of connecting these two things to actually take this real-time data and push it into that machine learning platform that I mentioned earlier. So 2016 is going to be a really, really interesting year. I would love, hopefully, to come back next year and tell you where we are then, because I think it's a really, very exciting. It's a very, very exciting topic, and it's really kind of cool to be at the kind of the bleeding edge of media, right? So that's really all that I have. We have a couple of minutes for questions. Please make sure that you take a moment and hit joined in, give me some feedback, leave feedback for all of the other speakers that you've seen. It's really, really very important to us. Helps us make better talks for you guys. So thank you. Any questions?
That's a very interesting talk. It's very good to hear the experience. We're using Kafka as well, so and we're using Spark Streaming for the real-time, not analytics, but statistics with Elasticsearch. So just out of question, of interest, you still use RabbitMQ. Have you considered to replace this with Kafka as well, or there's good use cases for RabbitMQ in these other scenarios?
I mean, we kind of compared the two when I was building the system. I went with RabbitMQ mostly because I don't need the persistence that Kafka gives. Kafka actually can handle a much larger load of data, but we're not at the point where we're kind of pushing up against RabbitMQ's limitations, so it didn't really matter. In 2016, like I said, we're going to be moving all of this stuff into Kinesis in Amazon, so it's going to be interesting to see how that plays out. But probably not Kafka anytime soon. Any others? Sweet. Go eat lunch.
Okay, that's great.
Thanks.